in the simulator now, it has the right like ending criterias for whether or not the campaign reaches certain levels and things like that. And so I'm very excited to like see what you thought and
how we can make this bigger without spending years on each little part. Like with Haskell. I had a quick look at what you have done, and let me just understand the pieces. Like so okay, we start off with what's that, 1 million? Yeah, 1 million WTIM. And then this says
this if observation now is important to start with, because before any other deposit needs to take place ever, there always needs to check to make sure there's still the, I guess maybe we don't need this one at the very beginning, but I wasn't sure. You'll see that on the next level down too. I have it too for like the second deposit.
What's the 9 mean?
Well, so the choice bounds between deposit is 10 and 50,000. So I wanted to, you know, there has to be 10 in there for someone to be able to make another deposit, because if you can only deposit 10, like 9 is the cut, I guess.
Okay, so you said greater than 9. Okay, which is greater than or equal to 10. That was the thinking.
Yeah, great. Yep, exactly.
Okay, let me just have a look at observations. So there's greater than, or there's greater than or equal to.
Okay, that would be a better choice then, I think.
We'll leave it as this, but like we'll change it later. Just because I don't want to go looking for all the places where it's probably only in a couple.
It's only a couple. Let's do it now, because then it'll be kind of like, let's clean this up like you kind of would. I see what you're saying though. So we can use 10 instead of 9 in there.
It's just what I like about that is that it's more like, so we'll just move that and we'll make that a 10.
Makes it more relatable.
That number then is the actual price, right?
Yep.
Whereas
the actual minimum,
like, so cool. So we've got greater than or equal to, and then we'll do this one like that too.
You could just duplicate that brand new observation too. You're already there though.
Oh yeah, actually, because it's the same thing. Anyway, sorry. It's a 10 there. Cool. All right. Because then we're multiplying it by 10 here, and in the Haskell code, we'll pull this into an actual variable, so it's easy to generate contracts at different prices and stuff. But cool.
And you'll see the important updates really from the last contract is a little bit lower in the payout. So before, in the contract we were working on, they were depositing and they were immediately being paid tokens before the next deposit came. And so now it doesn't happen until no one is paid out, until all deposits are made, and then the total of those deposits have to meet the halfway threshold of available tokens to be a successful campaign.
That makes sense. Let's see. So we've got an if that person's been paid. Sorry, if we have more than the half available, then we pay that person and that person. Else, if there's
less, the campaign doesn't meet the like halfway mark, which we're saying is the threshold for success in it, then everyone gets back their ADA. They're not given the tokens, they're given their ADA.
So the only thing I'll say is that the way if else works, right? So your if condition here is if it's greater than 500,000. Is that 500,000?
50,000.
50,000. And and then you've got an else if it's less than 50,000. And that's kind of implied by the else. So we can just simplify a little bit. So this if is fine, but then like if
I
so
see
if
what
you
you're
go into
saying
if,
down at
then
the.
you do this bit. Otherwise it's the opposite of that condition, which is the less than here anyway.
So
I
you
think
could just
like
take the if out and put the pay straight in there.
yeah,
Gotcha.
yeah. And then
Makes
you don't have
sense.
to worry about this else clause because you didn't know what to do in the else case, but it was like an impossible case anyway.
Yep.
So that's
Makes
just
a lot
little
more
bit.
sense.
Yeah, cool. Okay, that's nice.
Yeah, it cleans up the readability of it too, even. It's like,
yeah, a little bit. It's just yeah. So in code you would write maybe, you know, this is the less than case, but yeah, we've got these blocks. So okay.
and this one is based on, so if someone deposited, like someone can, maybe there was only one person that supported the campaign, and of
Yeah.
course it wouldn't be able to reach the halfway threshold with just one depositor. When it timed out, it was going to pay back that one depositor, because otherwise, if you don't have this condition in here and you have one person deposit and the campaign closes, it just takes that person's money and doesn't
pay them anything.
Doesn't give them any. Yeah.
So that's basically a refund there as well. So it's kind of the same code as this.
Yeah, it's just a refund in case a campaign only has one investor.
Does it only in the case of one?
It's only in the case of one.
Okay, cool. Okay, great. And then we've got some timeouts here. Okay, great. So yeah, really good work on this. I think like we've, you know, those edge cases are important, so thank you for thinking about them.
Yeah, this really makes it this framework, I mean, people can change the criteria of what you know, how many tokens they get in exchange for ADA, and it's like they can also set parameters for like the minimum threshold and maximum thresholds. It really kind of makes a really pretty feasible crowdfunding campaign.
Yeah, I agree. All right, so what I'm going to do, can you see both my tabs here?
Yep.
Is the switch between them? Great. Okay. So I'll go into the Haskell editor now, and let's move this to Haskell. Let's tidy up a few things before. We'll tidy up a few things. Basically, the goal being to move it to something that has a few parameters about what these numbers are. So like these hard-coded numbers, we'll make them parameters to we'll make them something that you can configure inside the Haskell program. And then on top of that, the main thing we want to achieve by the end of this lesson is that this can grow to any number of investors. So the basic plan is to just like generate this thing, but with, investor 1, investor 2, investor 3, investor 4, investor 5, up to whatever, some number.
Well, until the campaign times out or it reaches the maximum threshold and just automatically closes.
Yeah, but you see the way this campaign works right now. Like if we put an investor 3 in there, just because we have an investor 3 in here doesn't mean that 3 investors have to put in. So like if the first 2 put in and the campaign closes, that's fine. That like the contract is still over. So I think that's what's really good about this contract, that we can kind of build it up to a maximum size, and then any number of people up to that maximum size can deposit.
I like it.
Yeah, which is like, and then I guess in a follow-up, once we get to the Pluto stuff, then we can get rid of the maximum size and make it like a dynamic thing of, as many people as join can deposit, but that'll be later. That'll be in another lesson once we get to the Pluto stuff. Anyway, so yeah, let's view this as Marlow and let's paste it into Haskell. So we're here. We'll start like that. So again, a Marlow contract, there's basically just a Haskell value, so you can just put it in like that.
Gotcha.
And then we'll do some refactorings here and there, and then we'll get to the generalization. I think the refactoring first is quite important, because otherwise we just won't know what we're doing, because it's too big. Like, it's not too bad, but it's 200 lines.
Yeah, this was because we didn't build out a bunch of deposit instances, was really able just to create the framework to start with just two.
Yeah,
it didn't get out of control.
Yeah. Anyway, we should be able to tidy it up a little bit more so it's manageable from code. So the first thing I'm going to do is give this token a name, because it shows up in a lot of places, token. Yeah. So I'm going to take this and I'm just going to call it.
And what does Ada show up as, or Lovelace show up as in the code?
Ada shows up as 2 empty strings like this.
Yeah, that's right. Okay.
Yeah.
So how those 2 token things won't conflict? Token.
No. So because that's like so this thing says, I don't know what
you're saying now. I see it.
But yeah, it's a value. So like a WTIM is a token of WTIM, and then Ada is equal to token like that. But you don't need to.
And I see how that relates to something in the. Can you go to Blockly for just 1 second? Because I actually had this question and I was trying to figure out why in. See, with the very first use case, token, currency, and then there's a form field.
Yeah.
But when I tried to put something in it, it disappeared.
Yeah, it's a good question. I don't quite know off the top of my head. I'll have to look at the Malo documentation of what that first parameter actually means. Token with currency and token name.
So I thought one was like the name of the token and one stood for the token symbol, but the thing is, it wouldn't let me put anything in there. Like, try to type in there right now, and I think it just will go away. So, yeah.
What if we put in a number? Oh, so it takes a number.
Oh, okay. It takes a number token.
What does that mean?
Yeah, how does that relate to?
Because we've already got a number here.
Well, let's not get off track. That's something.
Yeah, let's not get off
I just
track.
had a question.
Yeah, it's a good question, and I'll try and investigate it. What kind of number should go in here? It's clearly validated to take a number, but I'm not quite sure what it should be. Okay. So yeah, there's an Ada equals token like that. But this basically, when you're using Malo Haskell, it already defines Ada for you, so you don't need that one.
Cool beans.
So I'll just start doing some of these. It was here as well, wasn't it? Yeah. This is just a small little refactoring to start with. It doesn't, it doesn't get us much, but just.
Well, I think, it does kind of just ease the real readability, just seeing WTIM Ada, WTIM Ada.
Yeah. What else have we got? So what have we got now? Technically, yeah, there's another Ada. So what I search for is token space, right? And that should tell us where they all are. Ada. So now there's only the one on top. So cool, we're done here. Okay, let's make sure it compiles. So you'll see me hitting that compile button a lot. So after doing a few of these, in earlier lessons, Boone, that we've kind of done, like, we've tried to refactor it from various directions, from the outside in, from the inside out. And I think I think inside out is the best way to do it now. I'm kind of confident about that. So what I'm going to do is.
And by saying that, you mean start with the end of the contract.
Yeah. So what I'm saying is what I really want to do is like take one of these payouts, which is like kind of the, you like, I don't want to start refactoring from up top here.
Gotcha.
We'll get that. We'll end up there. What I really want to do is take, write a little function for something like that first, and then we'll get one for that, and it'll kind of
Gotcha.
grow out. Like, and that's just you'll see why it ends up being quite nice. So we'll take this. So this is a payout, and then the other thing is this is a refund. So what I'd like to do is do the payout first and then the refund and pull that into a function. So we'll take this most inside one and we'll call it payout. Sorry, we'll just make it a contract for now. I don't know, maybe it doesn't have to fit on one line, but.
I just like watch and learn from, people. When you do things for a while, you come up with styles that work for you, and they're usually based on some type of logical work process. So
yeah, largely like, I don't know, I guess like I'm not really actively thinking about it. It's just gonna go like, so I think this is small enough to kind of fit on one line. But you may disagree. Which is fine. So that's our payout. Like that's our investor 2 payout. So the first thing I want to do is take that investor 2 string is obviously hard coded, so we want to generalize it a little bit, and we want to make it like investor 1, investor 2, investor 3, depending on the parameter that we passed. So we'll change this function from an integer to a contract. And so that function will now take investor index, something like that. And now we have to make these roles from an investor index. So I'm going to just pull that into a different function. So actually, this is going to complain this type, but that's okay. Let's just see what it tells me. So investor
and this is in regards to the contract building out each one of the investors in the contract.
That's right. So we want to use this for investor 1, investor 2, and especially when we get to like 100, then we want to, we don't want to hard code these.
Yes.
So that's what we're getting for. Okay. So there's a little bit to unpack here, right? So there's a index is an integer, IDX for index. Yeah. So there's a function show in Haskell, and this is general Haskell, nothing to do with Milo here, which converts basically whatever it has into a string, like into a string that the user can see. So for the case of an integer, it just converts it to a string. So what we're talking about is going from a number like 1 to a number, to a string like 1. That's what show does. And then we append that to, we append investor to that number.
Gotcha.
Next thing, we have to call this from string. And I just know because I was doing this before, we have to actually import data.string from string. I think this is the only import that we're going to need. But roughly, without going into detail, Haskell has all kinds of strings. Like it has text, it has byte strings, and then it has these strings that you kind of just put in, and they're by default interpreted as lists of characters. So from string basically converts it to from one of these ones that we just put in to whatever is needed. So it kind of avoids me having to know exactly what type of string role needs. I think it's a byte string or something, but I'm not 100% sure. So from string kind of takes care of that for you. It'll convert it into the right type.
Gotcha.
So at this point, let's just compile because this is almost definitely going to give me an error. Right. So this type is not a role, it's a party. So yeah, basically, you can have a role or a private key, and both of those are a party. So that's why, yeah, the type is called party, but what we're actually calling to construct this thing is a role.
Gotcha.
So that should, I hope, compile.
And party really relates to a specific block in Blockly too. Like the
no,
same.
party. What it relates to is, for example, we'll just place it here. So party can be either a specific public key or a role.
Gotcha. Yeah.
So it represents a person, I guess. Like if you're, so yeah, you can hard code a public key, or you can use these roles. And the goal of the roles is that you can, you can generalize these contracts to, like, I can run this contract with whoever, in this case, the pool is this public key. In this case, the pool is this public key. So you don't have to hard code the address of it here. So I think in practice, always just use roles. But yeah, anyway, so the type of this thing is a party, but these are the two possibilities of it.
I think, it helps me relate. So to think about every one of those things on that sidebar is a type in, right?
Yeah.
So the contracts is a type, party is a
Yeah.
type. All those
it's a little bit
types.
It's a little bit inconsistent because this says contracts plural, but it's actually the type of contract. I think observation is the same, actions the same, values the same, and then now we're in singular and they match. So it's a little funny, but that's
kind of funny. But it helps me remember, like when you're working on, when you do those things in Haskell that we were just working on, helps my mind relate to like even just understanding these contracts better.
Yeah.
And as a public key, can it be also address? Like
it's a good question. I don't know exactly what form, like if you use a public key case, I don't know what exact format it takes. Because remember, addresses and public keys are just kind of different representations of the same thing.
That's why it's interesting to know, because
I don't know what the format is, and I don't think we're gonna know until we have until we actually are able to like run it on the testnet and see what parameters we have to fill in for those roles. Then we'll find out. I imagine there'll be addresses, like, I imagine there'll be addresses, but like, just in Milo here, it says public key. So they're like, with these keys and addresses, there are so many ways of specifying them and they're all incompatible with each other. But I hope that when this is live, I hope that Milo kind of does the similar kind of thing that the various blockchain explorers do, and they let you paste in whatever you want and it'll work out what the format is and use it.
Yeah, that makes sense. Just because you never know what a user is going to really provide.
Yeah, yeah, yeah. The whole crypto space is so like like a little bit scary, right? Because you're always a little bit scared of when I paste this key here or when I paste this address here, will this treat it as the thing I want before I send money to it and forever lose it? You know, so far I haven't screwed up, but you know.
I think for the most, just thinking it out loud, I would assume that, you know, they really are going to have, that would support your wallet address, because I think for most, a lot of use cases you're going to see in the industry, you know, people are going to know their wallet address they want to receive tokens at more than like a public key itself.
Yeah. Yeah. So yeah, it's going to be a receiving address, and then yeah, what to do with a receiving address, right? And who actually participates in this? Like, yeah, there's a few questions to be answered there, and I really hope that, you know, once we have access to the Milo testnet, we can answer some of those. So these are all questions to be addressed in a future video.
Being Alonzo Gonzo.
Yeah. Yeah. Cool. Okay, so where were we? Cool. So we have this investor role here that goes from an integer to a party, and we've got the investor index here. So that's cool. Now, instead of writing role investor 2, we can say investor role investor index. So instead of hard coding it, we are passing that index to that function here.
Yep.
So that makes it a bit more general, and same diff here.
Takes it from a 2-person contract to a, in a way, unlimited, but I mean,
yeah. And I just realized now, I may be wrong, but it looks like this thing that I pasted is not a payout, but a refund.
No, wait, which one did you take?
Well, I'm just looking at what it is. I thought I took the other one, but this pays.
Oh yeah, it's paying ADA.
Yeah,
that is the refund.
So let's call it refund, because that's quite important. Yeah. So we'll do the refunds first and then do the same thing for payouts. They're very similar.
Yeah.
Okay. And so we're nearly done. The only thing left to do when processing this refund is that now we've got, like, we've kind of handled investor 2, but investor 1 needs to have this investor 2 part come after it, because right now we have a close. So instead of a close, we want to do an investor 1. So the reason, the way I do that is I pass another contract to the function, and that can be like called next or something. And then instead of closing here, we
Gotcha. Okay.
pass in next, right? So now it's completely general, because you're saying, yeah, create a refund for this investor index and then give us the next contract to continue with. So let's actually try and do this. So it's
That was the right one.
Yeah, that's the right one here. So now let's start with the investor 2 part.
I think that's the one you started with.
Yeah. No. Sorry. So what I want to do now is call that function here instead of. I'll show you what I mean.
Gotcha.
So,
gotcha. Okay. Gotcha. I see
so
what you're
with
saying.
Refund, and then the investor index is 2, and then we close.
Gotcha. Now I'm tracking.
And now, instead of doing this whole thing, it's a refund, investor 1, and then we refund investor 2, and then we close. So that's what that ends up looking like.
Gotcha.
Yeah. And let's just make sure it should compile, but you never know.
Yeah, we've done quite a bit to it.
Cool.
Boom.
Compiles.
Boom shakalaka.
Let's simulate it. So I guess we want to do the refund thing. So we'll just make sure that works correctly. So we'll just do 10, 10, and they should both be, yeah. So they got refunded. It still works.
Yep.
Cool. Okay. Now I want to do the same thing for the payout. So that's this part here. Again, I'm doing the 2-part, and then we'll generalize to 1.
Gotcha.
Yeah. So that was a refund. Now we got payout.
This is exciting seeing this come together like this, actually.
Yeah, it's always quite fun, eh? It's yeah. All right, so I'll tidy it up, and I'll just give it. We'll do, we won't mess around too much. So we'll do the same thing here. So it takes an integer. And the next contract, your contract, same as before. Yeah. So this, instead of being investor 2, it'll be investor role, and it'll take an obviously it doesn't matter what we name it, but it's good to name them consistently.
Yeah.
So that'll take an investor role, investor index, WTIM, then the small value. So just to be clear, that mole value corresponds to multiply here.
Gotcha.
Yeah. And then we've got a constant 10, and then we've got a choice value. One thing about using this web-based editor is that I don't know any shortcuts, so I'm quite, doing things quite manually, but it doesn't really matter. And then that's going to be that investor role again. And here, instead of just closing, we're just going to do next again.
Gotcha.
Like before. And one more. Cool. Save that. Should we call it?
Crowdfunding contract.
Crowdfunding Haskell version. Yeah. Cool. All right. So that's our payout. So let's actually put it in.
Right there. You just went. That's right at the bottom. Right there.
Oh yeah, there it is. So I'll do it from the inside out again. So instead of this part, we'll do a payout to close. And then instead of all of this, we'll go payout 1. So now we've got something quite nice. Like we've got, if the pool is greater than that, then we pay out 1 and then 2, and otherwise we refund 1 and then 2.
Yep. Awesome.
Cool. And yeah, before we count our chickens, let's just, what have we done? Cannot is,
Oh, I think so. I up at the top when you're doing the Haskell.
yeah.
I noticed in the first one you had a party. Yeah.
Yeah, my bad. Yeah, so you need this. Cool.
Boom shakalaka.
All right. So let's do the sufficient this time. So we'll do 30,000 and then we'll do 40,000.
That's right. Both people got paid their WTIM and the pool got paid the ADA. But now, just so people can understand the difference between if the two depositors maybe each only deposit 20,000.
Yeah. Yeah. So that's quite similar to, what we tried before, but it's, so if we do 20,000.
And this is the pass fail is all based on the meeting half of the campaign amount.
Yes.
So I mean,
yes. So at 20,000 each, we're still under the half. So now we got paid our ADA back.
Yeah.
So perfect.
Yeah, works perfect.
Cool. Okay. Cool. So that's quite nice. Now, now what I want to do is basically generalize this a little bit more. Let's just have a look at the bigger picture just for a second.
I think maybe your deposit is
yeah, the deposit is the next natural thing to do. Yeah, not the startup one, but this, I guess anything that has investor one, right? So let's see. So I guess like to me, it makes sense to do
their choice.
Like the choice and deposit together.
Okay.
Because I think that's what happens, right? Like we've got a choice. And then, hang on, sorry. Where do we start? So we got, if the pool has, then we got a choice followed by.
The if is based, so they make a choice and the if is based on if there's enough in the pool to meet their deposit.
Yeah.
And then they can deposit. If there's not enough to meet their thing, they can't deposit.
Yeah. Okay, cool. So we'll call it deposit and choice.
Or even choice and deposit is the order it happens in.
Yes, yes.
Thank you.
It takes an integer. And again, we know it's going to take the following, like what to do next. So we can just do that straight away. And it's going to return a contract. And I'm going to do the investor2 one. Whew, that's big. Okay.
No, you got too much there because you've got the payouts in there.
Oh, the payouts are going to come in because they're part of the next. Yeah. So hang on, we've got a when choice investor2. Yeah, we will need all of this, but we'll clean it up.
What if you start with number one though?
Same thing as before. We're doing inside out.
Gotcha.
So we'll do 2 and then kind of grow it out. Because the reason I do inside out is basically because it just makes the recursion a little bit easier.
Gotcha.
So mainly that we don't have to immediately think about the recursion. So we're here. Whew, okay. Yeah. So it's when we get to the. Oh, have I gone to 1? Yeah, or have. Oh, that's investor 1. I'm sorry. Let's just go back to 2. All right. Cool. So that's what we have. And let's just do it. So we can get rid of that. I'll just compile, make sure all my brackets are matched and stuff.
Boom
Great.
shakalaka.
Okay, so the first thing I want to do is take this part and move it to make it its own function. So like we'll call it payouts or refunds.
I see how you're refactoring it now. Why you started with the larger chunk. I got it.
Yeah, so that's this part here. We'll just try and kind of write it in a semi-readable way. So we'll do the whole if condition in one line. And then we'll do the then condition. I wish I knew how to just unindent. In this editor. I'm sure there's a way.
Yeah, I'm not sure. I'm sure there is though too, or I hope there's a way.
Yeah. So I think that should satisfy all of. Cool. And we
Nice.
don't need the outer brackets, so it's even nicer. Yeah, cool. All right. So let's start. So basically we do payouts or refunds. So yeah, we're doing the whole deposit, and then actually, and just there's another step here that we're going to do, which is instead of hard coding payouts or refunds here, we're going to go next instead. So basically the idea being that instead of always doing payouts and refunds in this choice and deposit thing, we will pass it what to do next. So then we'll call it with payouts and refunds later. So we'll do choice and deposit to payouts or refunds. That's what it's going to end up looking like. In fact, as soon as we've finished this refactor, we'll do that. We'll put it in so it's clear what we're doing. Anyway, so this is going to be investor role and investor index, just like before. I'm going to paste that a few times. Cool. So that's that, except for that's if that's the payout, the one.
Yeah, that's the single investor use.
Yeah.
Use case.
Okay. I'm gonna add another parameter here. And it's going to be like, we'll call it on timeout. And then we'll pass in that. Basically that.
I don't know if it matters, but on that last choice deposit you made, the last contract you added, I think it's still touching the arrow. Does that matter up at the top? You got contract.
Oh, no, it doesn't matter, but
Okay.
thank you for, yeah, you don't need those spaces really. They're just, but it's kind of nice and readable to put them in. Cool. All right, so choice and deposit 2, payouts or refunds. And this is just, we don't need this code exactly like this because we've got refund. So we can just go refund 1, close. Cool. So now we've got this kind of general choice and deposit function. Now we can actually replace it here. So all of this now. We're only talking about investor 2 right now. We still haven't completely up to here, I guess. I'm just a bit paranoid, so I'm going to save it at this point. Oh, and I lost my selection. Let's just go back to it. Choice for investor 2. So this whole thing can now go. And it can be replaced by that. So, yeah, we're saying if the money available in the pool is
less than the minimum threshold,
then we've got that. Otherwise, we close the contract. Okay, so let's compile. Boom. We've done something weird. Is this an issue of name? Let's just call it something. Sorry, did I say payouts or refunds? Yeah, no, I said choice and deposit. That's right. I'm just going to call this something else. Just to check if it's a name issue or something else. So choice and deposit takes an integer and a contract. That's a contract. And then, oh, that's going to be a. And then another contract. Let's try that. Used in a top level splice quasi-quota annotation. It must be. What's going on here? So if we just do a close here, just to understand what's going on. Now it's complaining about refund. Oh, I'm sorry. Yeah, I just had this function call sitting there on top.
You just
Yeah,
had saved that for him at
yeah,
the
it
bottom.
was just, yeah. So it should be, oh, now it's gonna be yes, like that. I'm sorry, I had a brief moment. And then we got that refund one close, which has to be a big C.
Nice.
Cool. If we send it to the simulator, yeah, well, let's do like 40,000 here. And then so that's investor one, and now we've got investor two, which is in the Haskell code, so that's more interesting. So let's do 30,000. Check if that still works.
Yep.
Yeah. And let's reset and do start simulation again. First one can go 30,000. I said did 40,000 before, so do the same thing. And then second investor can do 5,000.
Nothing. Oh no, they got paid.
Okay, that's not good.
Wait, what did you put in there? You put in 40. Oh, you put investor two
I put
deposit
in
50,000.
50. Okay. Yeah, that makes sense then.
Just have them both do 10, 10, 10, 10.
No,
Deposit
I
10.
need the first one. Oh yeah, sure. Yeah, 10, yeah. Yeah.
Now
cool.
they get back their money because it
yeah,
didn't meet
cool.
the threshold.
Yeah, so it was just a typo while testing. Cool. Now, now I see that one mistake I think we made is that probably that choice and deposit should have had that if around it.
Well, does it matter? I mean, won't it be, does it need, so it needs to be called each time
Yeah,
someone
just to tidy up our recursion a little bit, I'm just going to put it around. It's not going to be a big deal. So choice and deposit is going to be like that. Yeah, so basically I will open that bracket and put that when in there. And then come back all the way here, close it, do a close. And I think that's it. If I remember correctly. No, what's it complaining about? Okay, hang on, let me just roll back a bit. Okay, I'll actually tidy it up a little bit. I'll just say guarded, or safe choice and deposit maybe.
Yeah, that makes sense. Safe choice.
And we'll take these same parameters as here. And now we'll just say, where's that if up to here? And then, yeah, basically instead of doing that chosen deposit, instead of doing that specific one, we'll just say chosen deposit investor index next. Yeah, so we just, it's basically this function does the same as that, but wraps it in that if.
Gotcha.
Okay.
Always checks to make sure that there's enough
Yeah.
of the fundraising tokens to be paid to the deposit.
Yeah. So now in here, when we get to it, we can just get rid of the if outside of this. Compile. No. Okay, what have I done? So it was like this, and that compiled. Did it? No, oh, okay. Let's, yeah. It just tells me I gotta compile more often. Oh, it needs one more. I was just missing that parameter in the type. So
You changed the naming at the bottom though too, when you were, I can't remember what you changed.
I
The
rolled
safe,
it.
the safe choice. There we go. That's right in there.
Yeah, so that's got to be safe. And then we've got to get rid of the if and close. And then get rid of a couple of brackets, compile.
Nice.
All right. And now here's the cool thing. So we already, let me just check safe chosen deposit just to make sure it does the right thing. Yeah, so, so that's saying if the pool has money left. Okay, sure. So then investor one comes in. They make a choice. And yeah, okay. So investor one then comes and makes a choice, which is
How much they wanted to, how much ADA they want to deposit.
yeah.
And then the if
And then
is based on if there's enough of the fundraising token to meet that deposit.
Yeah.
And if there is, then it allows them to deposit.
So I'm just wondering if is that necessary? Let's just go back to here just to understand this part, right? Because
well, it's necessary
have-
that there has to be it's first that's first making in the select how much they want to deposit, but then it's making sure that there's enough of the crowdfunding tokens to meet that deposit, right? So someone can't come in and maybe there's only 100 left in the pool.
Yeah.
But they just said they wanted to put 500. This is to prevent them from being able to deposit.
Yeah. I'm just wondering, does this not cover it? Does this not cover the maximum? No.
No,
it
because
doesn't.
it's dynamic on the
Yeah, I understand. And then just wondering, does investor two have the same thing? It does.
yeah, it always is checking to make sure that, because depending on the conversion rate of someone's crowdfunding thing, they might be giving out 5 tokens or 100 tokens per ADA deposited.
Yeah. So does our Haskell have does that, I'm just looking at whether our function already has that. So choice and deposit. So we do a choice and then, oh, there it is. So, okay. So we've already done this check here. Yeah, okay. Sorry, I got a little bit flustered. No, we're all good. So we have done save choice and deposit to here. So now what we can do is basically take this whole thing. Right? And replace it with one of these save choice and deposits again. So it's is it a when? No, it's actually up to here. Too far. Just go a little bit slower just so I can actually, so it goes up to there. So now we have that already. And now we can just say save choice and deposit 1.
Gotcha.
Followed by save choice and deposit 2. Now, and I guess if 1 doesn't choose or deposit, we can just close here. Have we matched the brackets or have we? I think we've matched them.
Compile when in doubt.
Yeah.
Nice.
All right. So
Wow.
yeah,
man.
nice.
We're really getting this chopped up down.
Yeah.
Yeah.
Yeah, kind of okay. Oh, we've compiled, so let's simulate. So it should be the same. So let's do the happy case. 40,000 and then 30,000.
Yeah.
Yeah, that's correct. Let's do a sad case.
That stays the same.
That stays the same. 10, 10. Bang back. So
Go
yeah,
on.
it works. Cool. Yep. But the great thing about it now is that it's like almost trivial to add another case. So like, let's just, before we do the recursion, we're like, let's manually add another case, because it's like literally like we can make this 1, 2, but instead of payouts or refunds, here we'll just do another 3 and then payouts or refunds. And here's the one that I'll just close here for now, but that's something, this point here is something we have to think about. But I'll just close it for now just to, and then payout or refunds, I guess that's the one that's also got a payout 3. And refund. Something like that.
You have an extra on the bottom. Payout on either where you copy it and paste on the very bottom.
Oh yeah. Cool, thank you. Yeah, I use this editor as a scratch pad, but it's really not. it's a that compile. Cool.
Nice.
So yeah, basically that's let's run it. So we should have 3 now, right? So we'll start with 10,000, and let's do like 40,000. 30,000.
Look at that. Investor 3 came to the table.
Yep.
Nice.
20, 30.
I'm kind of interested. Will you do a reset and do a use case where let's have the third one come in over what's available? So
Yeah.
like put in a lot with
Yeah.
number 1 and 2, and then put in a lot with number 3, and let's see what happens. 50 or something. 50 and 40, and then like 50.
Okay, and that's over it, yeah.
I think so.
Okay. Oh, so he still tries to deposit.
Well, let's see. Maybe it's not enough. Put it in. Maybe we didn't go high enough. No, see, someone was cheated. Investor 3 was cheated. He should have got 500,000. So we have to have something that it shouldn't have let him deposit.
Yeah, correct. Okay, let's have a look at why. So let's send this to simulator. What I'm going to do is open up another one of these. Copy this generated code. Got a new project. Blockly. US Marlow. US blocks. All right, so we'll zoom out a little bit because it's getting bigger. Investor 3. So if 10 times. You know what the issue is?
I can't read it. It's too small.
Oh, no. But even like, here we can zoom in, right? So we've got a value here, which is basically what investor 3 has put in, and we're checking whether investor 3's available currency is equal to the total of is less than or equal to total available currency from the pool, which is fine, but the pool hasn't paid out anything
Oh,
yet.
that's right. The pool hasn't paid out. That's right.
Yeah.
It's look so all these cases are actually wrong then in a way,
except for the
because
first. Yeah.
they're always looking at a pool that hasn't paid out.
Yep. That's a bug.
Interesting.
So, yeah. All right. Well, how do we fix it?
Yeah, we might not be able to do it. I mean, I know we're getting over.
Yeah, let's do the recursion.
But it's something to address in the next.
Yeah, I'll show you quickly how you'll address it because I've done this before. But I won't actually like fully address it. But essentially, what you'll do, right, is you'll do a let. I think that's here. So you'll go initially let, I don't know, outstanding be, a value 0. And then each time they deposit, you'll do like a, let outstanding be plus plus, you know,
Ah, I see what you're doing.
yeah, we'll add them together. Oh, yeah, we'd probably start with the initial and go minus instead, same concept. And then we'll, instead of checking the available currency, we'll check out this outstanding value. So I'll leave that as maybe homework for you to fix in your one.
Yeah.
But let's, what I want to do is just finish this kind of Haskell thing that we've been building up to, which is generalizing it to, you know, any numbers.
Yep. Thank you though. Yeah, I'm glad that you saw that, because I didn't even take that into account, that these if observations were observing a pool that wasn't paying out.
Because I think it was correct when we initially did it, because we immediately paid out. But
Yeah.
now that we're moving
Yeah.
all of the payout to the end, then we have to,
Yeah.
Cool. Okay. Where are we? Here. Yeah, good. Okay. So the final thing, I guess, is the final thing is to do this in a more general way. So instead of like yeah, basically instead of hard coding these 1, 2, 3, we want to generate it based on a number
On the fly.
Yeah, like at compile time though, not at contract runtime. So the contract is still finite, but we can do any size contract we want. So
Gotcha.
compile time fly. Okay. So we'll call it, we can do this one first. Rec for recursive. And that'll take an integer and another integer, you'll see why. And return a contract. Now, actually, let's just separate things a little bit. So just the refunds for now. So it'll take a current number that's going to be like 1, 2, or 3.
Gotcha.
And then a max number. And yeah. So what will it do? Well, so first of all, I'm going to show you some probably new Haskell syntax that you haven't seen before. And that's this idea of guards. So this is what it looks like. It's like an if else. Basically, that's what we're doing. But yeah, just so essentially what we want to do is, I guess we've been using 1, 2, and 3 all along. So we'll say, yeah, like for this case, the current is going to go 1, 2, and 3. The max is going to be 3. So what we really want to do is handle this like case of what happens when we go over 3, then we close. Right. So basically, if we say if current is greater than max, then it's equal, then this function refunds rec is equal to close. Otherwise, it's equal to refund and we'll give it a we'll give it the current. And then the max is max. And sorry, what am I doing? So we'll give a refund of current. And then it's gonna, that follow-up contract here. So current is this, and then we've got a follow-up contract. So if we're here, then current is 3 and the follow-up contract is going to be close. But here, we're not just going to hard code close, we're going to recurse into this function. So refunds rec of the next one, current +1. And the max is going to say the same. So that's kind of what we, that's what we want.
And this is just and this is to create the, you said the recursion, the continuation, investor after investor after investor after investor.
Yeah, exactly. So here, instead of having this 1, 2, 3, we'll say refunds rec 3, 3. No, sorry, we'll start with 1, 3. So it's just going to go 1, 2, 3.
But now, just as simply in that one little spot, you could change that to 1,000.
Yeah, 1,000.
And then the contract can have 1,000 depositors if it took that many to reach the.
Yeah, exactly.
And then in that same use case, though, if it was like 1,000, if it on the 1,000th, it's going to look at the amount in the pool, and if it's reached the threshold or hasn't reached the threshold, it's going to refund, right? Is that what we're saying? Gotcha. Okay.
Yeah. So let's compile it first, make sure I've done this right. Obviously I haven't. Let's see. Oh, I just gotta, this has to be in brackets, because otherwise it doesn't know whether this 1 and 3 is a parameter to if or to my function. Cool. So it should work the same. But let's make sure that we're doing the refunds case, because that's the thing we've generalized. So all 3 people should get refunds. So we'll just do 10, 10, 10. Yep. 3 refunds. Great. Okay. Now, so that's the refunds. Now we want to do the payouts, which is like going to be the same. So that's gonna take, I'm just gonna like paste this whole thing.
Yeah, it's the same exact thing, isn't it? Just the
only thing that's different is we're gonna pass in payout here.
Yeah.
Instead of and payouts rec. Cool. So, and now here, instead of saying payout 1, 2, 3, we'll say cool.
Okay, better compile. Nice.
All right. So let's do the payout case this time. So we'll just do 50, 40, 30. No. 50, 20, 10.
You could probably just do 10, 10 now and it'd still work, I think. Because the first one at 50 should have met the threshold.
Yeah, true. I've done something wrong, haven't I?
No.
No.
Yeah.
No, that's it. Yeah, cool. Okay, so we got that. So now we can keep moving out. So this time payouts or refunds, instead of hard coding 3, it can take an integer. and max. So instead of going to 1.3, 1 max, and then
Awesome.
whatever calls, payouts, or refunds.
I don't think you've saved in a while either.
Okay. This one I'm confident in. I don't even need to test it. Cool.
Nice. Yeah.
Now we've just got to do this thing. Save choice or deposit rec, which is going to be like the same. So that one takes, where is it? Well, it's going to be the same again, right? Integer to contract, because now we don't need all these callbacks, because we don't need these contracts being passed in anymore, because we're working, like, we've got them all passed in, and now we're just working from the outside in, really. So, well, it's pretty much the same, right? It's so now, yeah, if we go over, then we close. Otherwise, save choice and deposit. What have we got? This one will still need this one's a little bit different. Because
What are you talking about, Aaron? What part are you thinking?
we got to do this one. We got to do this one close refund. But yeah, so how are we going to do this? I've got a clever way of doing it, actually. Okay, so this one's still fine, and we'll just close on everything, just for now. So save choice and deposit, save choice and deposit rec. So we'll give it a current save choice and deposit rec max, and it's gonna need a close here, because that's if we look at save choice and deposit, it takes 2 contracts. So one is the recursive one and one is the timeout thing. So that should technically work.
Nice.
Cool. And now we've got to replace this very carefully, though. Mainly that I want to keep this refund 1 close in the special case that there's only 1 person.
Yeah.
And I think we might have to generalize this soon. We might have to do a few bug fixes and some more generalizations later. But like, so I'm going to leave this, say this 1 without recursion, so it can take that as a parameter for the 1 person.
Makes sense.
And what I'm going to do is recurse from 2 up to max. So
that makes sense. Because that one is just a special
yeah. Yeah, basically, yeah. So it's going to look like that. And now we'll do 3 just to test the whole thing. Oh, let's just, so then that can take an integer here. Cool. And then when we call contract, now we'll call contract with, I don't know, she'll get a 4. Let's just try it with 3 first. So we're comparing apples with apples. I think. Yeah, let's just match these brackets. What have I done?
You do, and I think you got an extra one after that.
There? No. Let's just. I would, so that refund, that matches that. What happens if I do it without that outer close? Will that save me? Maybe, maybe not. I think I needed it. No, that compiled. Okay. So we'll do the happy case again. So 30,000, 40,000, and 40,000, and 10.
10.
Really? Yeah. Cool. Yeah, so that's,
No, something's
what did it do?
deposit 10 into investor pool. The contract pays 22. It didn't, that close was important because now it didn't pay any of the it took the deposits, but it didn't pay the
Let me just take us back a bit. Should this compile? No. I'll just take us back a little bit further just to see what I've done here. So that's what it was, and that worked. I think it worked. Ah, I know what I've done. Yeah. So we've done a 1. And then it's this part here that we need to replace with 2, 3 for now. All right, I've done the same thing as before. So this compiles. Let me just carefully. That compiles. Okay, so this matches this matches this, so that's 3 case. And then okay. So that's where I had it wrong. Yeah, so 1 deposits, that's and then if 1 doesn't deposit, we close. Then 2 is a special case because 2 is the one that refunds. 2 is the one that refunds that refunds 1 if 3 doesn't come in.
no,
So
the
it's
lack of 2. The lack of 2 refunds 1.
Yeah, sorry, the lack of 2. So yeah, but that's right. This contract for 2 also specifies the lack of 2. So the lack of 2, which means 2 is a special case as well. And then this general case is here.
Yes. I think
Yeah.
I think now I think that's probably the
Yeah.
makes sense.
So there we got a 3-3 right now. Let's just test it.
Yep. Good catch.
Okay. So 10. And then we can go 30. 30. 10.
No, it still didn't pay the depositors.
Why not? What have we done? Oh. I know what we've done. Yeah. We need to tell it. Let's just roll that back to, let me just get it back to what it was, like that. So we don't, yeah. Save, choice, and deposit is slightly different, the recursive case, and wherever it is here, because here previously we shouldn't be closing after the choices and deposits are done. We should be doing the next thing. So we'll pass it a contract, and then if we've gone over the max, then we return the next thing. So then we want to go save, choice, and reposit rec 3.3, and we pass it a payouts or refunds 3, right? Instead of closing there. So that should now. So yeah, we do 1 and we do 2, and 2 refunds 1 as a special case. And then we go into this recursive case where and this is where the payouts or refunds happen when this finishes. That was the problem. We were just closing. Oh, yeah. And that's just complaining to us that we haven't passed that next case to the recursive case. So yeah, we added a parameter, but we didn't pass it into the recursive case. So that fixes it there. Cool.
Nice.
So now that worked, and I'm pretty confident it'll work now. So 30,000. And then 20,000. And then 10,000. And they're paid out now.
Nice. There we go.
Yeah,
Back on
so
track.
just that, yeah, like that's what happens when we paste, I guess. We don't think about the pieces. Okay, great. So now we are pretty close. All we want to do is make that max parameter. So and now we'll have 1 and 2. Or not gonna think about the problem where, like, yeah, not gonna think about what happens if you put in a 1 or a 2. I'm just gonna assume it's a number bigger than 2. So that second parameter is gonna be max, and payouts or refunds, it's gonna be up to max. And now we've got to pass that. We've got to pass that max to there. So let's make it 5. Let's go big. All right.
Nice.
So now we've got. Let's put 15,000 for all of them. Let's see what happens.
Oh, investors are just coming in left and right now.
Yeah, yeah. This is what you want. Cool. It's 4 times 15 enough, and I'll just do 10 for the last one, just to. All right, so we paid.
Nice.
To investor 5. Now, one thing I want to Okay, yeah. So I think that basically concludes our lesson. But I can think of a few things that still need fixing. So I'll just briefly talk about what needs fixing here, and then we'll fix it in the next lesson. One is what we already talked about, which is accumulating a total, so that so that basically
so that it's actually checking that there is the right amount left in the.
Yeah. The other thing is we're gonna have to think about how to, like, I think when I'll show you what I mean. I think there's a bug also. Sorry, let's just send this to simulator. So investor 1, 10,000. Investor 2, 10,000. No one else comes in.
It should refund.
So what happened? Yeah, it's not right. It didn't refund.
Yeah, it's missing the.
So I think we've got the refund if investor 2 doesn't come in, but we don't have the refund if like, it's actually more general than that. If investor N, if investor 5 doesn't come in, then we've got to check, like, on the timeout, we've got to check, have we got enough money in the pool, and pay, and either pay out, if we do, then pay out 1 to 4. If we don't, then refund 1 to 4, right? Because we've got that special case for 1, but there's, now that we've got more than 1, it's a little bit, it
Well, it was the original contract was paying out a refund on the 2.
only if everyone comes in, like the original one.
Oh, that's right. Only if. Okay, I see what you're saying now.
Yeah.
Okay.
So we've got to handle that timeout case. So there's a couple of bugs to fix, which I think we can just carry on, and then the next time fix those
for sure.
And we can fix those. And I guess it will be quite good to, because like, just where we're going from here, I think, like, kind of as far as presentation is done, I think we're done. But like, where we're going from here is, we can fix those bugs in Marlowe, and I think we should. But what we also want to do is present the same contract in Plutus and see what the differences are. So I'm just trying to think about timing this.